Assalamualaikum warahmatullahi wabarakatuh and good evening. We are from Group A and my name is Zulfadli binti Zulkarnain. Today I will present about timber. So I will explain about introduction. Okay, definition of wood. Wood can be defined as the material that forms the trunks branch of tree. Timber wood cut from the trunk which can be used for constructing houses, furniture, bridge and others. And for lumber totally is used in US to signify such as sawn and work timber.
Treatment and curing. As we all know, timber can easily decay by swelling, fungi, insect, fire, and etc. Basic approaches is to create conditions unfavorable to fungi such as low humidity, heat, and water insulation. The first method is oil-type preservatives. The oil-type preservatives require the moisture content should not be more than 14%. It is to apply over outside of exposed timber. It can be cause unpleasant smell, and it is not suitable when timber is to be painted. The example here is the first one is creosote, carbolinium, and solidum. The second method is water-soluble preservatives. The water-soluble preservative require the moisture content of 20% to 30% is permissible. Odorless organic or inorganic salts and adapted for inside location only. And the example of leachable types of preservatives. The first one is zinc chloride. It is divided by two. The first one is sodium fluoride. The second one is sodium pentachlorophenate. Both of them is toxic to fungi, expensive and odorless. The second one is boric acid, also known as borax. It is used against lactase borers and to protect plywood in tea chests. The other type of water-soluble preservatives is copper chromate arsenic composition, acid cupric chromate composition, chromate zinc chloride composition, and solvent treatment.
The third one, we have various treatment processes. The first one is surface application by spraying, dipping, and brushing the preservatives for a short period, at least 2 coats. The preservative here refers to the previous slide, which is the 2 types of preservatives, the oil type and the water soluble type. At least 2 coats here means at least 2 layers. And then the subsequent coats should not be applied until the first one has completely dried. This means if you want to, for example, if you want to apply shellac on the wood surface, you have to wait for the first layer to completely dry. Only then you can apply the second layer, because you want to get a decent or a nice looking of the wood surface. It is used mostly for treating timber at site or retreatment of cut surfaces. The second one is soaking treatment. We immerse the wood in a preservative solution for a sufficient period until the required absorption of the preservative is obtained. The third one is the hot and cold processes. This ensures sterilization against fungi and insects. The timber is submerged in the preservative solution, which is heated to about 90 to 95 degrees Celsius and then allowed to cool until the required absorption is obtained. During the heating period, the air in the timber expands and partially expelled. While cooling, the remaining air in the timber creates a partial vacuum, which causes the preservative to be sucked into the timber. Generally, we have 2 baths are used. The first one is containing the water to prepare the hot treatment, and the second one is the cold bath containing the preservatives, where the timber is transferred immediately after heating. This to avoid the precipitation of chemicals at high temperature. It also helps to let the process continuous in case the timber quantity is large. Next is Boshery process, and the fifth process is the full cell or Bethel process. It is a pressure process used when maximum absorption of the preservative is desired. First, the charge of wood is sealed in the treating cylinder, and an initial vacuum is applied for approximately half an hour to remove as much air possible from the wood and from the cylinder. The preservative, either heated or at ambient temperature, depending on the system, enters the cylinder without breaking the vacuum. After the cylinder is filled, the cylinder is pressurized until no more preservative will enter the wood or until the desired preservative retention is obtained. At the end of the pressure period, the pressure is released and the preservative is removed from the cylinder, and a final vacuum may be applied to remove the excess preservative that would otherwise strip the wood. For the last process is empty cell process, which also known as pressure processes, aimed at a maximum penetration of the preservative with a minimum net retention. Lorry and roping processes are commonly used. Both processes use compressed air to drive out a portion of preservative absorbed during the pressure period. However, both processes are used widely and successfully. For roping process, compressed air is forced into the treating cylinder containing the woods to fill the wood cells with air prior to preservative injection. Pressurization sometimes vary with wood species, which means for some species only a few minutes of pressurization are required, while more resistant species may require pressure periods of from 30 minutes to 1 hour. And then after the initial pressurization period, the pressure is raised above that of the initial air and maintained until the wood enough absorbed to leave the desired preservative retention level after the final vacuum. After the pressure period, the preservative is removed from the cylinder and surplus preservative is removed from the wood with a final vacuum. This final vacuum may recover from 20 to 60% of gross amount of preservative injected. For lorry process, it is an empty cell process without the initial air pressure. Preservative is pumped into the treating cylinder without either an initial air pressurization or vacuum, trapping the air that is already in the wood. After the cylinder is filled with the preservative, pressure is applied and the remainder of the process is identical to the roping process. The advantage of the lorry process is that full cell equipment can be used without the accessories required by the roping process. The accessories here such as air compressor, extra tank for the preservative, a pump to force the preservative into the cylinder against the pressure. Next is the timber product. As we all know that there is a lot of timber products out of our syllabus, but we'll be only focusing on few timber products. Okay, the first one is veneers. It is used to decorate furniture for residential projects, hotel projects, or offices. The characteristic is it is a thin sheet of wood, and it is manufactured in various grades, which are veneer parquet, flexible veneer, sheets wood veneer, boards wood veneer, and wallpaper. It is popular to make a furniture or concrete mold. Next is plywood. Plywood is used in beam making. It is an assemblage of wood veneers bonded together to produce a flat sheet. As you can see in the picture right here, plywood is much thicker than veneer, so it explains that it is an assemblage of wood veneers bonded together. The third one is durable, and the last one is easy for designing, for curve shape, structural, exterior, interior, or even marine. Next is boards, a thick board, stable dimension, two types, namely particle board and fireboard.
Wood in construction, timber, used for structural and non-structural member in construction. Example of structural member is house, column and bridge. And for example for non-structural member is furniture. Structural purpose is the properties have to be compliant with the MS 544 standard requirement. First, furniture. There are 4 common trees that we use to make furniture. First, leban tree. Second, jati tree. Third, gading tree. And last, arang tree. Furniture. Common types of tree that we use to make furniture is leban tree, jati tree, gading tree, and arang tree. Properties. First, this wood always small size and expensive. Second, strength and durability. Third, wood furniture is very effortless to maintain. And last, the value of aesthetic because wood's natural grain guarantees that each piece of furniture is unique. Next, house. There are 5 main components in houses that we can use timber. First, piling foundation. We will use bakau, kompas and keruing. Second, mas, balau merah, cengal, keruing and meranti merah tua. Third, door and window frame. Usually we will use meranti merah muda and meranti kuning. Stairs, keruing, kapur and mengkulang. And the last 4 floor, we will use bintago, sepital and cengal. Benefit of timber is more ecological and economic alternative, keeping the house cool in the summer and warm in the winter. Lastly, to have a smaller carbon footprint. Next, for bridge, we will use cengal, resak, merbau. This wood is used to build high structure and exposed to weather. This wood is strong and soft, even easy to work but expensive. This load-bearing structure is formed from laminated wood beams along the leg of the bridge. Column we will usually use balau merah or cengal. Advantages of wood column is we can increase the insulation by reducing heating and cooling costs. We can also cut down on your heating and cooling costs because wood is natural product. And the last, wood absorb moisture, which helps regulate humidity in a room. It can increase humidity.
Timber testing. For timber testing, we have 8 methods. First is specific gravity, volumetric shrinkage and swelling, static bending strength, impact bending strength, compressive strength, tensile strength, brittleness test, and moisture content. We go first to the specific gravity. Specific gravity is a scale that indicates a substance density. The amount of moisture will influence the weight of wood. Woodworking industry will influence the dimension of a piece of finished lumber as the cell expand or construct based on their moisture content. Specific gravity of wood is determined by measuring the weight at a specific moisture content level, and every wood has a different specific gravity. That's why each wood species ability to float and sink in water. Volumetric shrinkage and swelling. Shrinkage is a reduction. A basic measurement of shrinkage expressed as a percentage is the amount that the wood shrink when going from its green to oven dry state. Kalau kat sini kita boleh tahu yang untuk shrinkage daripada green kepada dry. For swelling is an increase of the dimension of wood due to change of its moisture content. The swelling of wood as manifested by the external dimension change vary with the specific structure, density, drying condition. We can see that the shrinkage for green lumber and dry lumber. Untuk calculation, kita akan ambil 3 bahagian iaitu tangential shrinkage, radial shrinkage and longitudinal shrinkage. Untuk volume shrinkage, kita akan tambahkan semua daripada tangential, radial and longitudinal. Untuk swelling, kita dapat lihat yang kayu dia sebenarnya membengkak. Okay. Objective of volumetric shrinkage and swelling. To examine the radial, tangential, longitudinal volume shrinkage of wood sample using green to oven dry method. Second, to examine the radial, tangential, longitudinal volume swelling of wood sample using oven dry to green method. And last, to calculate the percentage of radial, tangential, longitudinal and volume shrinkage and swelling of wood sample. For the procedure, we need to measure the radial, tangential and longitudinal surface of wood sample at least 3 direction selected point. And then weight wood sample using the loading balance. Place wood sample in the oven at a temperature of 105 plus minus 1 for 24 hours. And then remove the wood sample from the oven and let it dry in desiccator for 1 hour. Measure the radial, tangential and longitudinal surface of oven dry wood sample at the same point before drying. And then place the wood sample in the water for 24 hours. And then obtain the dimension of the soaked wood surface. The measurement must be done as the place. The formula for percentage shrinkage and the percentage of swelling. The formula is initial dimension minus with final dimension divided by initial dimension times by 100. So we can get the percentage of shrinkage and the percentage of swelling. For static bending strength. Bending, also known as a flexure, characterize the behavior of slender structure element subjected to an external load that applied perpendicular to a longitudinal axis of the element. Kita dapat lihat daripada gambar ni, daripada timber yang tegak, kalau kita bagi external force dekat bahagian tengah, dia akan bend seperti gambar ni. The objective of static bending strength to obtain a approximate of the maximum load and load of the proportion of timber for bending stress and modulus of elasticity (MOE) of timber. Second, to obtain the value of the deflection versus the applied load. And lastly, to classify the bending failure according to the appearance of the fractured surface. Compressive stress. It happens in long, slender structural elements such as column. An increase of compressive force F lead to construction failure due to buckling at lower stress than the compressive stress. Compressive stress ni kita akan memberi force daripada kedua-dua arah, iaitu dia masuk ke dalam, dia akan jadi, kayu tu akan merekah di tengah dan pecah. Compressive stress objective is to obtain the approximate of the maximum load and of proportion of timber for compressive stress or modulus of elasticity (MOE). And then to identify the type of failure when the compression parallel to grain. This is the formula for compressive stress at maximum. Load equal to P over A, where P is maximum crushing and A is a cross section area. This is the example of the calculation that you can You can refer. Tensile strength. Tensile strength is a measurement of the force required to pull something such as rope, wire or a structural beam to the point where it breaks. Brittenell test. Brittenells identify material easily broken, damaged, cracked and snapped. Brittle material are characterized by little deformation, poor capacity to resist impact and vibration of load, high compressive strength and low tensile strength.
Last, moisture content. Objective of this experiment is to determine the moisture content using two methods. First, oven drying and moisture meter. Moisture content defined as the weight of the water expressed as a percentage of the moisture free or over dry weight of the wood. Formula for the calculation of the percentage moisture content is original weight minus oven dry weight over oven dry weight multiplied by hundreds. The equipment for this experiment, we will use moisture meter, oven, digital and caliper weight scale. For the procedure, first, we will choose 3 species of wood. Second, for oven drying method, specimen should be cut to include the full cross-section of the sample. Next, take wood block weight. We must approximate to 0.01 gram reading. Put into the oven for 24 hours until weight is constant. Then take weight of the wood block. For the last, use for the moisture meter, take 3-point different reading. This is for example of calculation to find the percentage of moisture content. That's all from us. Thank you.